Good morning, guys. My name is Karthik. I'm currently pursuing BTech in SNU. We have been given 6 questions to solve for the maths NSEM examination, and now I'll show you the how to solve the second question. It is based on differential equations, and we'll directly get into the process. I'll explain you the process on how to solve the question. Let's go into it. I hope the view is clear. Yeah. Okay. For the second question, we have been given that under what conditions on the constants a, b, k, l is the ordinary differential equation ax plus by plus kx plus ly into dy by dx is equal to 0 exact. Solve the exact ODE. Okay. Now we have been given this equation. I'm just rearranging. I'll explain you. Is equal to minus of kx plus ly into dy by dx. Yes. Ax plus by into dx plus kx plus ly into kx plus ly into dy is equal to 0. I have simply rearranged the function. Okay. Now solve the exact ODE. We have been given 2 questions. Now first thing, what exactly makes the differential equation an exact differential equation? This is the main thing first. A differential equation, so the definition, guys, a differential equation is is of the form a differential equation of the form m of x comma y dx plus n of x comma y dy is equal to 0 is an ordinary differential equation, is an exact ordinary differential equation, is an exact ordinary differential equation if there exists a function, if there exists a function, if there exists a more precisely a constant function of two variables. For example, we'll take it as u of x comma y. It's a function with two variables, a constant function which is continuously differentiable and has continuous partial derivatives. Okay. So u of x comma y, we have said that it is a constant function. Yes. So u of x comma y is a constant function. Let's take the constant as c. Now du is equal to derivative. What is the derivative of a constant? We all know that it is a 0. Okay. Now du is equal to dou u by dou x. Since u is a variable in x comma y, du is equal to dou u by dou x into dx plus dou u by dou y into dy. Okay. Till here we got clarity. Now what should we do in the next step? In the next step, what we'll do is, see guys, dou u by dou x, dou u by dou y. Okay. We can simply write this as m dx plus n dy. Right. So we are representing m is equal to dou u by dou x and n is equal to dou u by dou y. Till here I hope it is clear. Yes. Now partial derivative of m with respect to y is equal to dou square u by dou x dou y, and partial derivative of n with respect to x is equal to dou square u by dou y dou x. Now after finding the partial derivative of m with respect to y and the partial derivative of n with respect to x, we find it similar that these two are same. So we can equate it as dou m by dou y is equal to dou n by dou x. Okay. This is a very important condition to prove whether it is an exact ODE or not. So this is a very important condition, star condition. Okay, now here take this, we'll use this condition here again. Take the dou x here and integrate. M dou x is equal to dou u, integrating on both sides. What will we get? U is equal to integral m dx, and after integration we all know that there should come a constant. Okay, there should come a constant, but what exactly is this constant? U is equal to integral m dx plus k of y. But how did we write the constant c as k of y? That is the doubt, right? So it has been written as k of y because here m is equal to dou u by dou x, and we have already clearly stated that u contains both x and y variables. So when you partially derivative the u with respect to x, then obviously all the terms which are present in y will become 0. So here if we don't use the constant in terms of the variable y, then we won't derive the function u, because u contains both x and y variables. That is why we write this constant in terms of y, or this can be written as simply, here we have used this condition and derived this. If we use this condition and derive, we'll get n dy plus L of x. Here the constant will be in the variable x. Simple, very simple. Okay. Now these are the criterias. These are the criterias to show whether a differential equation is an ordinary differential equation, exact ordinary differential equation. Now coming to the question, we have been given as ax plus by into dx plus kx plus ly into dy is equal to 0. Okay, now 1 second. Yeah, for example, this is of the form m dx plus n dy, right? M dx plus n dy. So we can equate m is equal to ax plus by and n is equal to kx plus ly. Okay, now I have already shown you an important condition. What is the important condition? Partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Very, very important. Now partial derivative of m with respect to y is equal to dou by dou y of ax plus by is equal to partial derivative of n with respect to x is equal to dou by dou x of kx plus ly. Okay, I hope it's clear till now. Partial derivative of ax plus by with respect to y is equal to, with respect to y we are doing, so x terms get cancelled. B 0 plus b is equal to partial derivative of kx plus ly with respect to x is equal to k plus 0. Therefore b is equal to k. This is the main thing we have got. This is the first main thing we have got. Okay, now going into the second one, finding the function u. We have to solve the exact ODE and find the function u. Now in the previous thing I have already shown you, u can be written as integral m dx plus k of y or integral n dy plus L of x. Yes, I have explained you this. Now u is equal to integral m dx plus k of y. What is m? Simple, I have already shown you ax plus by. Write it down, ax plus by dx plus k of y. Okay, now what is the integration of ax plus by? Ax square by 2 plus bxy plus ky is equal to u. Now how to find k of y? How to find the constant k of y? This is important. Now it is simple. Here in the previous page, guys, I have shown you, look at this, n is equal to dou u by dou y, right? N is equal to dou u by dou y. Write it down, n is equal to dou u by dou y. But what is n? What is n? n is equal to kx plus ly. I've already shown you this. N is equal to kx plus ly. Okay. But this is u. We have derived this term u. But we are in the process of finding the constant k of y. So simply replace this here. Dou by dou y of u. What is u? Ax square by 2 plus bxy plus k of y is equal to simple n kx plus ly. Okay. With respect to y, x terms gets cancelled. 0. I mean ax square by 2 with respect to partial derivative with respect to y is 0. Simple. bxy is simple bx. And dou by dou y of k of y is equal to kx plus ly. Here guys, we have already proved that b is equal to k. So obviously bx is equal to kx, right? Because b is equal to k. We can simply cancel this. Now dou by dou y of k of y is equal to ly. Okay. So k of y is equal to, taking this side and integrating, k of y is equal to ly dy integration, which is ly square by 2 plus c. K of y is equal to ly square by 2 plus c. Okay. Now what? Now it's simple. Simply putting this value k of y is equal to ly square plus c here where we have derived u. So writing it down again, we'll get it as u is equal to ax square by 2 plus bxy plus k of y, which is ly square by 2 plus c. Okay. I hope it is clear till now. Okay. Now we all know that u is a function in two variables x comma y and it is a constant c. So du is equal to dou u by dou x into dx plus dou u by dou y into dy is equal to 0. Don't you find this similar? Yes. In the first page I have already shown you. U of x comma y is equal to c. U is in a two variables function. It is a constant function and du is equal to this. Okay. Now we'll simply go do that. Now, and what did we get? U is equal to ax square by 2 plus bxy plus ly square by 2 plus c. So simply put that here. Dou by dou x of ax square by 2 plus bxy plus ly square by 2 plus c into dx plus dou by dou y of ax square by 2 plus bxy plus ly square by 2 plus c into dy. Oh, the place is less. I hope it is visible. Is equal to 0. Okay. Partial derivative of the entire u with respect to x into dx plus partial derivative of the entire u function with respect to y into dy is equal to 0. Important condition. We have already shown it before. Now partial derivative of this with respect to x is 2ax by 2 plus by plus partial derivative of ly square by 2 with respect to x is 0. C with respect to x is 0. Here it is x term, there is no y term, so it is 0 with respect to y. Don't forget that. bxy with respect to y is simple bx. ly square by 2 with respect to y is 2ly by 2. And what is c with respect to y? Partial derivative of c with respect to y is 0. Simple. So yeah, the zeros there have no use. 2 gets cancelled, 2 gets cancelled. So yeah, don't forget this. I'm sorry guys, it's a really big mistake. Don't forget dx and dy. Plus small mistakes guys. I'm sorry. This plus this is equal to 0. I'm really sorry. I've equated it. No, it has to be plus. I'm sorry. So ax plus by of dx plus bx plus ly of dy is equal to 0. What exactly is this? Don't you find it similar to the one given in the question? We have been given in the question as ax plus by into dx plus kx plus ly into dy is equal to 0. ax plus by into dx plus bx plus ly into dy is 0. Huh? How is it similar? Simple. Replace this b with respect to k. How can we replace that? Yes, we can, because we have already proved it here. We have already proved it that b is equal to k. So ax plus by of dx plus kx plus ly of dy is equal to 0. Hence we have proved this. Therefore the ordinary differential equation which has been given to us in the initial question, we have proved that it is an exact ordinary differential equation through this process. And what are the conditions in the process? We have also derived few conditions, that is b is equal to k for the constants. Therefore, thank you guys for watching this video. This is the process on how to solve the second question for the end examination. Thank you.